Good morning, everybody, and I apologize that I had to come only today, so I wanted to be on a main inventory session yesterday, but due to certain constraints, I have opportunity to present it only today. So I'm working at Natural Resources Institute Finland here in Joensuu, but the project what I will be speaking about today, I was carried out in one of the Russian university where I was implementing it for last 1.5 years. And I'll try to present the results on what we were able to achieve this year from this project. Actually, here in Finland, we are also running now similar project in Natural Resources Institute Finland, but we just started it here in Finland. But maybe I would more reference on results what we achieved in similar type of research in Russia. So I started my research with UAV about 10 years ago, and I was actually first one who brought civil UAV to Finland. So it was 2006, and we applied a huge all kinds of permissions to bring it to Finland from Canada, because at that time it was, autopilot technologies and it was not available, and we bought it for Mäkrijärvi Research Station for University of Eastern Finland here in Joensuu. And then we started tests, and of course that time, 10 years ago, UAVs were not reliable at all. It was crashing almost every second flight. But we were able to get some pictures, we were able to get some first results. At that time, we were able to get nice pictures. This is just old historical mosaics from 10 years ago. Pictures were nice, nice looking, nice areas. But when you start to build three-dimensional models, especially of forests, we are getting really low quality results. You see all the trees glued in together into one piece, and it was very difficult to make image recognition, to make individual tree crown delineations, and only on open spaces this was working. And at that time, I somehow lost for a while my interest towards UAV. But then a few years ago, I thought that, okay, the technology must be developing further, and started to continue. So this research is almost like 10 years matured. So there are a lot of progresses, but we try to solve those issues now. From a market point of view, I was motivated with one fact that in Russia, almost 82% of the forest inventory data in Russia is outdated. So from market point of view, it's a huge market with a lot of demand now, and also the laser scanning is somehow not common in Russia and even forbidden in some areas. So we thought that, okay, need to find some other solutions which could be applied, for example, in this market. And I made application and got the funding from one of the Russian sources, and implemented this project jointly with between Syktyvkar State University and Natural Resources Institute Finland, and funding mainly was coming from Russian side. There are also recently, from recent publications, there are kind of new directions in research, especially in forest inventory. For example, recently it was published several similar papers which are showing that it seems that when we start to compare LiDAR with the photogrammetry, nowadays we could get better results with photogrammetry than with LiDAR. And especially when I'm speaking better results, it's not only accuracy but also its costs. Because current forest inventory, which is utilizing LiDAR, is usually based on ideas that you get LiDAR data, and then you need to find somewhere spectral data to make accurate species recognition. And here, for example, if we use, for example, high-resolution aerial images, we could get all those three-dimensional data and spectral data at the same time. We don't need to fly a second time. And there are also a lot of drones, very cheap drones on the market. For example, this Phantom, it's not like everybody have it. And in Finland, for example, the price of it is about 200 euro. And with this drone, you can, for example, make a flight and you could get 50 hectares in one flight, roughly. So it means this is already on the market. And then there are a lot of developments going on. For example, there is one company, I think they are based in US. They made a multispectral camera, which is called Parrot Sequoia, and which you could mount on a Phantom. So almost with, let's say, within a few thousand euros, you could get a flying multispectral camera with all needed calibrations, and this is a really good opportunity for to develop the things. besides those small drones, for example, you could get very nice pictures from those small drones, like Winter Forest. It was taken about 1 year ago, and you see, of course, from altitude, from about 150 meters, you see individual trees, and you could even see single branches if you need, or single needles if you need. So you can fly at any altitude, but it's just we need to find a solution how to utilize this information. Besides those drones, there are of course better solutions on the market available. In that case, because this was Russian-funded project, we had to use for this purpose Russian drone. So there are, for example, we bought in Russia and we paid for it about 10,000 euro drone, which could fly in the air for several hours, which could carry out hyperspectral camera. And the most advanced thing that in this drone, there is a high precision GPS device installed. So this kind of, it's like a flying geodesist. So when you, after the flight, when the drone landed, you can do the post-processing of your flight coordinates, and then as a result, you get center of your images with accuracy of better than 10 centimeters. And then, of course, it's a good opportunity because then you could do the photogrammetric processing and get very good results from this data. So we were testing this drone with different flying parameters on different areas. And then one of the key issues, if I come back to the comparing laser scanning versus photogrammetry, as you can see on this first picture, when we are getting the laser scanning pulses, it's covering almost equally the study area. But when we are doing this photogrammetrically based 3D point cloud reconstruction, we are getting quite often not the whole tree, but just some parts of the tree which are in visual, which is visible for the camera. So what we started to do with the drone, we started to test this drone in different forest sites with different tree densities, with different number of trees per site. And then we developed a model, I'm not going into details, which is practically allows you to forecast what should be the flying parameters when you on different forest sites. So frankly speaking, if there is a big density of trees, the drone, when it's flying, it's taking more images from more different angles. Or if it's the forest is represented with lower density of trees, for example, classical 90 degrees imaging with 70% overlap will be more than enough. So we developed this model, and before we send the plane into the air, we can forecast the different behavior of the plane in the air, since we have some a priori data from, for example, which is coming from Landsat. And Landsat data, it's a satellite data, it's available for free all over the globe with a special resolution of 30 meters. So know-how here is how to forecast the different behaviors. So when we get the pictures with different resolution, with different viewing angles, of course, when we increase number of viewing angles, we could increase number of the three-dimensional point cloud. So there are better, bigger number of points, but then we are also increasing a special resolution of three-dimensional model of our forest site, what we are deriving from photogrammetric image processing. So the simple technology, what we developed, looks now, contains of those practically 3 steps. First, we fly the area with the UAV, and for testing purposes, we were using mostly quadrocopters. But the problem with quadrocopters are limited nowadays in flying time, so you cannot cover big areas with the quadrocopters. But if you know what kind of areas you will be flying, if you know what kind of viewing angles are suitable for those areas, then you could, of course, put the cameras and put the proper cameras on with proper angles, with proper spectral bandwidth on flying wings. So, and with flying wings nowadays, for example, with this model which is here, you could easily get about 1,600 hectares in about 1 hour with only one flying wing. And in this flying wing, there are 2 cameras installed. The cameras are on with different viewing angle. One is taking pictures from 90 degrees, and another is taking pictures from 80 degrees. But also the cameras, one is taking pictures in visual range, and another is in multispectral range. Then once you get the flight, you can get your orthophotos and then process it, the orthophotos both in visual range and in multispectral range. Then the second step, in order to verify that the trees what we are measuring photogrammetrically and using spectral data processing are the same what we can see on the ground, we establish the sample plots. So it means we need to go to forest, measure several sample plots, and when we are measuring the sample plots, we are measuring each tree position. And each position of the trees we are measuring, applying this so-called ultrasound device. This is Swedish Haglöf Postex. So it allows you to get exact coordinates on the trees. And this is needed in order to obtain the reliable estimation of the diameters later. And then finally combining the data with from a forest with the data from unmanned aerial vehicles, you get your final results, which are represented by the GIS layer, for example, of individual trees, or GIS layer of forest stands, and of course you get accuracy assessment report. So this is just an example of application of this approach in one of the company. And so this is company Mondi, operating in Komi in Russia. They are leasing huge forest, and they are also quite a big paper producers, so there is a pulp and paper mill. So we were flying one forest block which is about 1,000 hectares with this flying wing. Then we were able to derive orthophoto mosaics from the obtained images, and then when you derive the orthophoto mosaics through photogrammetric processing, you can split your 3D point cloud into like two components. So the first component is digital elevation model, meaning all the points which were on the ground, and then the second component is all the points which were not on the ground but on the trees. If you subtract from the your three-dimensional model digital elevation model, as a result you get canopy height model. So here on the canopy height model, it's all the points which are on top of some trees or some objects which are higher than the ground. As you can see, the quality of the digital elevation model here is crucial, but when you fly at the lower altitudes, we are speaking about 200 meters, 150 meters, you are getting pictures with about from 2 centimeters to 4 centimeters spatial resolution. And of course, when you're applying different angles, it means you are always able to see the ground. For example, maybe you can recognize on this picture, there are, for example, it was an old clear cut here. And you can see even from this three-dimensional model the small deformation of the ground which was caused by harvester or forwarders moving on this harvesting site. So as a result, when you have the canopy height model, then there are opportunities to interpret this model, and using classical approaches, you could, for example, get the single trees recognition, and from canopy height model you can identify the tops of every single trees and then delineate the crowns. So for example, with the methods we were developing here in this project, we were able to map all the single trees, and then field verification showed that accuracy was, the error in the tree number estimation was less than 1%. So for example, for this area it was about 100,000 trees mapped here on this site. So the images, of course, we are taking images from different spectral ranges. So this is a typical image in visual range, what you get from the UAV, from unmanned aerial vehicle. But then when you have multispectral camera for the same territory, you could get another type of imagery. And multispectral image is usually used for automatic species recognition, and accuracy with multispectral imagery is very high, so its error is less than 1% in single species recognition. Then after the photogrammetric processing, you get this canopy height model. Here it's canopy height model overlaid with on imagery, and you can of course measure the height of every single tree in the forest when you know the height of the trees, and then you know so the highest point on the treetop and then the lowest point on the ground. The point density here is huge, so we are speaking about 600, 500 points per square meter. It's much higher than, for example, with laser scanning you can do nowadays. And this is not because of the high resolution, but also because of the big number of, not big number, but several viewing angles and very high overlap. So if you have 2 or 3 viewing angles, and then you are flying drone in such a mode that it is taking at least 8 images from different angles for the same point, your number of viewing angles is really huge. And then interpretation of this three-dimensional canopy canopy height model. As a result, you can identify the single trees. So here we identified tree tops of all the single trees. And then when you can measure, segment the crowns, you could come to the diameter estimation. So what we can see actually from the imagery, we can measure the height of the trees directly from the unmanned railway vehicles data through photogrammetric processing. We can measure the species from using multispectral cameras or hyperspectral cameras, but this is nice. But what, as a foresters, what else we need? We need a diameter. And in forestry, mostly you are speaking about breast height diameter at the altitude of 1.3 meters, and this is, of course, you cannot see from the images. Sometimes in low density stand, due to the high number of the viewing angles and very big overlap, you could even see the trunks. But this is, let's say, more like exceptional cases. So to be able to reliably to estimate the diameter of the standing trees, you need sample plots and to be able to derive a local diameter estimation model. So for this purpose, we established the sample plots, measured all the trees which were on the images, and then measured for all the trees coordinates of each tree to be able to place it further on image. Tree heights, diameter and species. And through very simple equation, you can, using this allometric relationship, you can derive a model which would allow you to estimate with relatively high accuracy the diameter of the trees from the species, height and diameter of the crown, which you can measure from the images. So as a result, we get a distribution of the tree diameters over the study area. And of course, when you know the three parameters, height, diameter, and then species, you could easily calculate the volume, so growing stock of the trees on the area. There are a lot of opportunities to develop it further, and for example, with this project, we were also interested not to offer only this kind of low-cost tree-wise forest inventory, because it is limited by the flying time of the drones, but also here our partner was interested to get a technology which would allow you to estimate, to make an inventory of over the bigger area. And here we used an approach when we use a kind of UAV as a field plot collection. So we were designing some sample plots locations, sending the UAV. UAV was taking images from those sample plots, derived tree-level data, and then we were able to upscale it using this multispectral data from satellite data. So like nowadays there are good opportunities which, for example, provide this new European satellite Sentinel, and there are 13 spectral channels and the spatial resolution within those spectral channels from 10 to 60 meters. But the biggest advantage, you could get pictures every 5 days for any point on the globe, and it is available for free. So maybe only disadvantage is the really big size of the data sets, so it's very often more than several gigabytes, but it's covering huge areas. So we developed a technology where you could combine satellite data and UAV data to be able to estimate forest resources over the big area. And if you would compare the, for example, images from the Sentinel, so this is first two images are the images of the study area from Sentinel in visual range and an with infrared channel, and the last one is the images from the same image from the UAV. So you could develop an approach for estimation of the forest resources over the big areas. So as a conclusions, from my point of view, there are a lot of new applications, or there are a lot of new opportunities where we could utilize UAV data for forest inventory. And first main opportunity, it is now possible really to reduce the cost of forest management inventory. And cost reduction is coming from the approach that we don't need, for example, in typical laser scanning based project, you cannot fly something like 1,000 hectares. If you want to make laser scanning based forest inventories, you need hundreds of thousands hectares to be cost efficient. With UAV, any project from the size of, let's say, 1 hectare will be feasible and it will be economically efficient. It is possible to increase drastically the accuracy because the error of the height measurements using this data from UAV nowadays is no more than 10 centimeters per tree, so which is, from my point of view, very accurate. And then utilizing this data, we could really get so-called forest inventory on demand, so meaning getting the data when we need it, and it's very easy to repeat the data collection. It's scale independent, so any project is feasible. You don't need to go on the big areas, but if you run it on the smaller areas from 1 or 2 hectares, it is still feasible. But then nowadays, there are also so-called industrial UAVs on the market, which are, from my knowledge, are now able to fly up to 8 or 20 hours, so without landing. So it means with such a big devices, you could cover, of course, large territories. And then speed of this inventory is very high because in our project we were using cloud computing because for photogrammetry processing of those images from many angles, from many viewing points, you need a lot of computing power. But it is nowadays very easy to scale up with, for example, cloud computing. In we were even tested one of our application on Amazon cloud, so that the images we are processing in Amazon. And the speed of the inventory is high, and there are also more opportunities because with this tree-wise forest inventory we are getting new type of data. We are getting practically every single tree identified and every single tree measured. And with this type of data, it is nowadays, from forester point of view, even possible to speak about the new opportunities which maybe could be called like precision forestry. You know, there is a big mega trend which is called precision agriculture, when there is a management oriented towards every single plant, and here we could, I think, develop something similar, especially if this data could be combined with the harvesters and the forwarders, which are already going to this direction. Thank you.
Wow, thank you. That was amazing. Now, questions. Over there.
Yes. Is there any issues with like regulation against usage of UAV in general? I mean, it's a drone. Yeah. So
it is an issue.
Can you repeat the question first?
Yeah, the question was: is there any issue with regulations of using UAV in general? And maybe I could give examples for 2 countries, like Finland and Russia would be easiest. So in Finland, you can operate it for yourself if you are flying no higher than 150 meters. And if you're flying, for example, as a lookie, if we would fly for ourselves, it's no problem. But if we will start to do project for somebody else, we would need to apply for a special license from this TRAFI, the special agency which is taking care about all those regulations. So if you want to fly it on the altitudes higher than 150 meters in Finland, then you need to make some kind of to reserve some part of the airspace. And in this case, you need to announce it in advance to your local airport. But then the process is now in many countries, quite uniformed. And for example, in case of Russia, it was very funny when we started the project. It was a local law which showed that all the UAVs were illegal. But then in March, Putin cancelled this law. And now, for example, according to current legislation in Russia, you could fly it easily, any UAV, if you're operating it. But the only thing, you need to announce it. So they have a very similar system like in US. So you go to some internet portal and announce like, I will be flying this day, this time, and this airspace, and submit your application. And within few hours, you get an answer like, you are allowed or not.
Okay, good. More questions?
Doing flying between winter and summer and spring, what's the best season?
Yeah, thank you. This is a very good question, and depends for what kind of applications. Like for classical forest inventory would be summer and autumn. But for example, some of our industrial partners, they are interested about reducing the costs and very accurate timber measurements. And you know, having this so-called background information is somehow forcing us towards increasing the number of viewing angles and increasing the overlap between the images. Now you've seen the snow. From my point of view as a forester, right now is really the best time to fly, because you have calibration object always on the ground, and which is white, and you don't have this a lot of noise which is coming from this undergrowth vegetation. If you have this undergrowth vegetation, you need to fly lower, get higher spatial resolution, and of course it's automatically results in the data handling and the data processing costs.
Is this already in production use? Is there a company I can call and ask them to come to do these measurements on my forest, for example?
In University of in Natural Resources Institute Finland, we are now we started this. We just started a project, and we are now collaborating already with 3 companies from Joensuu, and one of the companies is Arbonaut, and we are so it's coming I think very soon. But nowadays there are many so-called UAVs all over. For example, in Joensuu, with few hundred euros, you could invite a guy who will come with his drone and take imaging over your territory. This is number of drones is very high. So the equipment itself is not an issue. So the data processing algorithms, this is the thing. So to get the images nowadays is so easy, but to get reliable results from the images, this is what is needed. And here we have an expertise. Of course, we have all the software. We're able to scale it up, not only at the, let's say, one single computer level, but almost on production level. Yeah. For example, now within this project, we are now cooperating with one of the company, which is called Ilim in Russia, and we are processing about almost 1 million hectares.
Wow.
So it's already in in industrial scale.
Okay, sounds very good.